for the to present. Ryan, I'm going to turn it over to you, but real quickly, just want to let folks know the title there is something I came up with based on some recent press for Cylance, and I absolutely love this. The Salem witch trials was eradicated by mathematics, and what I meant by that, very simply, that Cylance does something very different in a very different way, and people are threatened by that because they do something differently and they're effective at it. And the answer to Cylance is just going to get down to it. Ryan's going to talk about it, but basically it's the math. So if I look back to my days at EMC and I look Dick Egan in the eye, he would look at me and go, it's the math, stupid. So on that note, Ryan, I'm going to turn it over to you.
Hey, so can everybody see my my screen okay?
Yes.
Okay, good deal. So real quick, thanks for the great introduction. I feel like supposed to be fancier than I am. I wanted to start off with a little bit of background about Cylance and kind of how we got here. Back in April 2010, our founders were both working at McAfee. And those of you 7 years ago that were working in cybersecurity or working in IT and cybersecurity, you probably remember a DAT file that came out for McAfee that attacked the service host on Windows. And that was really kind of a bad day for all of us that had to run around and sneakernet patches to get things fixed up. That bore the idea that basically definitions don't work, that antivirus definition-based antivirus does not work. And there's a couple reasons for that. The first, of course, is anytime that you have this many humans, in the case of most of your traditional AV players, a couple thousand humans involved in creating DAT files, you're going to have problems. There's going to be mistakes. Humans are not perfect. The second thing, of course, is it's a reactionary system, that the reality is, in order for somebody to be protected, somebody else had to have gotten owned. The file had to get uploaded. The DAT file had to be then downloaded, and that time just doesn't work. Right now, according to the latest, I think it was a Symantec security analysis, there's about 1.2 million unique pieces of malware or unique hashes of malware that are coming out daily. So there's just no way that these guys can possibly keep up. So forward out a few more years and to 2012, and these gentlemen, Ryan Perma and Stuart McClure. Stuart McClure, you may be familiar with from the book Hacking Exposed, created Cylance, and back in 2014 created the Cylance Protect product that was actually launched. So I think this is if I could try and explain this as simple as I can, Cylance is a data science company, and that's important to us. So we're not just a security company out trying to solve it using data science. Cylance is a whole new approach in that we came in from a data science standpoint trying to solve the security problem. Just like, people are coming in and, coming with all sorts of, self-driving cars and medical diagnosis and all this kind of stuff based on data science. That's the approach that we're taking. We just happen to be applying it to, or at least, or limiting it right now to preventing cyber attacks. But in reality, there's going to be a lot more stuff. Stay tuned. That's going to be coming out that we're going to be doing as well. But the big thing is, if you look at the market, 2 years ago, if you were at RSA or Black Hat, you would hear nobody ever mentioning data science, AI, machine learning, artificial intelligence. Those words were never used out there. And suddenly, 2 years ago, we're showing up on the scene, and we're been very disruptive to the scene. And now, when you go to, it's like the buzzword BS. You see, everybody is doing AI, machine learning, AI, machine learning. And one of the key differentiators that I wanted to point out in this line here is that we are doing this before they ever execute. So Cylance is a data science company that leverages artificial intelligence to prevent cyber attacks by blocking them on the endpoint before. The key there is before. That's really what should be underlined, before they ever execute. So a couple quick kind of interesting things there. But obviously it's a very disruptive technology out in the cybersecurity world. So a quick other couple things about what we do. Silence Protect is what we're going to be playing with today. Silence Protect is an antivirus replacement. It does not use signatures. It does not require online lookups. It is managed entirely by the cloud, but that's what we're going to be playing with today. But there's a few other parts that we do also offer. Silence Optics is actually going to come out in a week from today, actually. That's an EDR system. And then Silence Consulting Services does all sorts of crazy things, from incident response to compromise assessments and all that kind of stuff. So I'm trying to go really fast here. I'm going to play with do some demo here, where we're going to be playing with some malware, and I want to go as fast as I can so we can actually get into the fun stuff, which is playing with malware. So a few things about what Silence Protect does is it blocks the malware using math, no signatures. The updates come out every 6 to 10 months, and there's a few other parts to it though, where you can it has exploit prevention, like HIPS is a term you see it referred to. There's also a whitelisting, application control is what we call it, but there's a whitelisting for devices that you can truly lock down, that like a server or a point of sale terminal, something like that. And then device control, so that you can control USB or CD-ROM devices on a computer to keep data from being exfiltrated. So there's a few other parts there. It's not just a one-trick pony. So one of the big focuses we're seeing out in the world right now is that you have to have EDR. And I'm not going to tell you that you shouldn't have EDR. EDR is a great way to go if you have something protecting you to begin with. EDR, for those of you that aren't haven't hung out in space a lot, EDR is endpoint detect and response. And so what the idea is that EDR is basically putting it's like putting a video camera system in your network. It's going to tell you what happened, who did it, where it came from, how it got there, and where and what left. However, all of that is after the fact. So the point here is, if you use traditional AV, which realistically is about between 40 to 60% on how good of a day they're having, effective against standard malware, you're going to be using your EDR system to find so many things that it's like finding a needle in a haystack. However, Silence Protect will catch 99.7% of known and zero-day things that haven't been seen yet. It will catch 99.7% of those files. So now you're trying to find a needle in a much smaller space. And if you have EDR, now it becomes a truly useful tool because you actually have the time to use it. So without any more delay from that, I want to jump on over to our demo environment. I'm going to show you some kind of fun stuff, playing with a little bit of malware here. So bear with me just. What I've done is we've been doing all sorts of different demos over the last, well, I've been with the company for about a year and a half. And we used to do a demo where we would go around and we would show our malware. We'd grab 100 samples of malware and we would try and detonate it on ourselves and try and detonate it on our competitors and see who caught how many. And it was pretty fun demo, because you would see a machine get cryptoed right in front of you. And it's nice when it's a machine getting cryptoed that you don't have to fix, that doesn't contain any data. But over time, that was very disruptive, and to be quite honest, a lot of our competitors have changed their EULAs and other things to prevent us from doing that anymore. So at this point, we're doing things a little bit differently. But what I did to start off here is I grabbed a set of malware that I downloaded way back. I think it's over a year old. In fact, I know it's over a year old. So I did, 2016 April. Is when I got these pieces of malware. And there's 100 samples here. This is how we used to do it. And these are my original samples. So what I wanted to do was just pick one. And this is old, easy malware. Everybody should catch it. So what I was going to do is just grab this, and let's see how everybody can do to catch it. So I'm going to grab, like I said, I just grabbed one randomly. Hopefully we haven't played with this one before. There's a couple different sites out there where you can get files. You can check files and see if they're malicious or not. VirusTotal is one that everybody's familiar with. However, VirusTotal, they will also upload that sample to all the AV vendors. So I'm going to start playing with some cryptors and packers here, and I don't really want to upload that special sauce up to them. So we're going to use another one. This one is called No Distribute. I've been having some problems with it recently. Sometimes it doesn't work and it says everything is clean. So we'll try it and make sure that it is working before we start by checking this old file and see how it works. So bear with me for just a second while we're uploading this file, and we'll see what happens here. So while we're waiting for this, one of the unique things about Cylance is that because it's a mathematical model, it's a predictive system. It will go out and it will detect malware completely using no signatures, completely by artificial intelligence, but it's a predictive system, meaning you can actually detect malware with it. It was written long after or compiled long after our math model was compiled. The way it works is by looking at up to 6.2 million unique features about a file to figure out exactly what if that file is good or bad. So it's taking a while. The fun part about using tools that are commonly used by the hacking community, of course, is that half the time they don't work. And it looks like we're in that fun area today. I've got another one here, OpSWAT Meta Defender, the same exact kind of thing. And so we'll try this one instead. There's our file. Open it up. And we're uploading the file. Will not take too long. And there we go. Our file is now uploaded. And so 27 of 40 all catch this as some kind of, looks like this is part of a package of some kind of a crypto locker. So there's a few that don't see it as bad, and that's not terribly abnormal. We kind of see that fairly common. So let's just remember that 27 of our agents thought that this file was bad. So let's play with this file a little bit. Back out here, and let's fire it up with the cryptor. And see, we may not even be able to crypt it. We may have to grab a new file. We'll give it a shot. So we're going to pick this is a stub file that one of my coworkers, John Miller, created. You can actually build a stub by using another file, and that's what this part here is. So it's going to tell you what it's going to try and look like. Let's just change the icon just for fun. I'm going to make it the process. I've got Process Explorer on here. There it is. Open. And let's get some random mutexes. Let's make sure we change our icon. And let's see, we'll turn on anti-sandboxing. So some of these other things like delay execution, we can put it in here so that if you were to put it in a sandbox, it would wait 15 seconds before it executes. So these things are very simple to modify. If you're anybody's using any type of sandboxing system, it's really easy to get around that. Those systems are going to fire up the file in a contained environment in a sandbox, and they're going to see what happens. And it's real simple. If you want to make something not look malicious to those systems, we'll just have it delay 15 seconds or 30 seconds, and the sandbox isn't going to think that it's actually malicious. So that kind of technology is very easy to bypass. So I'm going to go ahead and hit protect. And yes, we're not going to do anything bad with this. We're not going to upload it. I agree to all of that. And we'll save it on the desktop. We'll call it, process with it. We'll put the S's back in it. PROCES.
Hey Ryan, while you're putting this all together, we're about 8 minutes for the end of the half hour, and at some point here, can you kind of make the transition over into talking about the WannaCry virus and talk about how we can stop things of that nature? I mean, go ahead and complete this. It's very interesting, but I want to make sure we cover that before the time's up.
That's actually a great current event. So yeah, I think I'm almost there actually. So
cool.
As you see, we've got our Process Explorer. It looks just like the real Process Explorer. But let's go to our file, and let's make sure we upload the correct one.
So let me guess who the one is.
So what I'm doing, everybody that's out there in the internet world, is I'm doing part of what we call the Underground Tour. This is something that's just actually was launched last night here in Vegas. But the Underground Tour, they actually are going to do this with ransomware as a service and teach somebody and they actually teach the people in the room how to do it themselves, how to go out using Tor browser and create ransomware, set the accounts and all that stuff. So Avira is the one that caught it, and this file is now completely, as far as everybody else and their brother is concerned, this file is completely fine. Now, in no way do I think that, am I saying that Avira is going to be better or worse than any of the other? We could redo this system again and have exactly a completely different result. So every time we do this, it's always a guess to me as what is going to happen. So let's see if Silence catches it too.
So this should be where the value of Silence, using the mathematical models, should be able to figure this out. Never seen it before, doesn't know about it. It's unique, but it should be able to find it.
Exactly. The idea here is that this is a new file. There's no hash. We just established that there's nobody can detect this file. I just copied it onto a read-only share. So we can grab it here. And since we're actually talking about the WannaCry, which is something that tries to run without ever being saved to disk, I'm actually going to try and run this straight off the network. And as you can see, it's now saying it can't run the file, and unsafe file detected. So there you go. That is typical of how Silence does. This works exactly the same online, offline. Obviously, this hash of this file never existed before today. So there's no way that any cloud lookup could have done anything to help anybody. And I want everybody to see that the transparency in what I'm doing, that this is how everybody does things. Now, WannaCry, since you asked about that, we are getting down to about 5 minutes left. WannaCry was kind of a fun thing. I had gotten up early that morning, so I was right at the front of when we saw it as a company. WannaCry is a piece of malware that exploits a vulnerability in Microsoft Windows Server message block, the way that machines talk to each other. It's another form of malware, and it also is encrypted. It comes in as multiple pieces. There's droppers. It's a fairly complex piece of malware. And so this thing came in. We got our copy. The copy that I got actually came from the phone company in Spain, Telefonica. So they had, by this point, with the time zone changes, they had sent all of their people home, basically saying, turn off your computers and go home. We can't deal with this right now. We need our IT staff downtime to deal with this before we turn all the computers on. So they sent everybody home. We got the sample, and the first thing that, of course, one of us did is we got the sample. We also verified that we had the correct hash from them, and we downloaded another copy of it to make sure that we actually had a good, healthy file. And we ran it on a normal machine with just Microsoft AV on it, and of course it immediately cryptoed the machine. The machine was in bad way. We then grabbed the current agent of which literally the VM that you just saw or you're still looking at. We grabbed that VM, and I did the exact same thing on there. I attempted to run it on the VM, and it was immediately, just like I did right now, and it was immediately blocked, just like you're seeing here. I got a wild idea, so I went ahead and grabbed a version 1370 of this machine. And so this is basically using a math model that was released in October of 2015. And so, well, I wonder if that old model can still detect it. And in fact, actually, the old model detected it and performed identically. By the way, when I did both of those tests, I was offline. I was not connected to the internet. Later, I found out that one of our other engineers had an even older one, the original ones that when we started selling the product about 2.5 years ago, version 1320, and he did the same thing with the same files. And actually, by then, we had collected from a few other places about 15 different variants of the malware. And one variant, what we did get was corrupted and would not run, and that one we did not flag either because it was a dead file, but all of the ones that were still functional, it caught every single one of them. Another one of our engineers, she's based out in Chicago, decided to turn our auto quarantine off, and so disable the math. The coolest part of the whole product is the math, and so she disabled the math system, turned off auto quarantine, and just let it run with just our memory protection, our exploit prevention, to see what would happen, and our script control. And in fact, part of it did run. However, part of it was blocked, and it was unable to crypto the machine. So even if our math model had missed it, the memory protection on the endpoint would also have prevented it from at least being able to crypto the machine, although some of it in that case did run. But for us to basically turn off the protection and still be able to protect it kind of says something about basically the 2 layers built in there. So it was definitely a wild, crazy day for us. Lots of information and questions coming in and out. But anybody that had silence on the machine was fully protected. Actually, they were fully protected from that malware for 2 years before that malware even showed up or that Microsoft exploit ever existed. So that's kind of how it works.
Real quick, let me interrupt. So I think this is a real relevant, conversation. If you think about this variant of the malware that's out today, it's going to morph itself multiple times into multiple variants, and people are going to be faced with that same sort of threat. So how will Cylance handle that going forward?
Just like you saw what we did today with a piece of malware that's a year old that everybody catches, after you can morph it all you want. Those features, malware is still malware. If the features are there that enable it to do malicious things to the machine, then those features will be detected by the math model and it will catch it. So if somebody is to mutate it enough to break it where it's no longer malware, then we wouldn't catch it anymore. But then it wouldn't hurt you either. But as long as that malware is what it is, we will still catch it. As much as you mutate it, pack it, change it, whatever you want to do, we'll still catch it.
So just a note as we kind of wrap up here. You know, it's one of those things, folks, where you need to kind of see it to believe it yourself. And we here at cStor have actually done our own test with our own malware that we've downloaded from, I won't mention the sites, but various sites, Malware as a Service or wherever it may be. And the same results for us as we just saw, you know, where Cylance basically caught 99 out of 100, and that's pretty much what they state in their literature, marketing literature, pieces of malware. And the other 4, you know, products that claim capabilities in this space let through anywhere from 28 to 38 pieces of malware. And that was on testing that we did ourselves with our own changes and our own variants. And just, you know, it's powerful, it works, it's a different way of thinking, a different way of working. And this is part of what cStor does, is we find different technologies that make a difference in different ways. You combine this with a dark trace, so we use the similar characteristics, but from a network perspective, and you end up with a really powerful solution. So,
Yep.
Ryan, with that, I think we're probably ready for a few questions, and we probably need to...
We are actually. That was the main question that was coming in, Walt and Ryan, was about the WannaCry threat and what companies can do today to protect themselves against it, if it's still an ongoing threat or if it's something that's really behind us.
So it is definitely still an ongoing threat. We're still seeing mutations come out right now of new variants of it that are coming out that are getting past traditional signature-based AV. So it is still an ongoing threat. Now, there's 2 sides of this threat that need to be thought about. The first, of course, is if it comes in through phishing, through whatever method that it actually gets onto the endpoint, that has to be prevented, and that is ultimately going to boil down to whatever you're using for your endpoint protection. This isn't something that, because it comes in as multiple pieces, this isn't something that a network device is going to do very well on protecting you from. This is something that it all is going to boil down to the endpoint. So having you know, good endpoint protection that's going to catch it is your first step. Now, assuming that fails for whatever reason, nothing's perfect. We don't claim to be perfect, and nobody is. Assuming that fails and it runs on one endpoint, if you are completely patched and the Microsoft SMB vulnerability has been patched on those machines, then it will stop, and that's the end of it. You'll just have one infected machine that's going to try and encrypt those files. However, if you are not patched, it is technically this, we're calling it malware, we're calling it virus. It's a worm. It will jump from machine to machine using that Microsoft exploit. And so in that case, and that's what happened to the phone company, the one I was more involved in, that's what happened to them. They were not patched, and it jumped from machine to machine to machine. So Windows updates, once again, are absolutely critical here to be able to stop it from traversing your network.
Great, thank you. So for the Windows updates, Ryan, are one of the takeaways. Can you give us maybe one or two other key takeaways from today's session?
As far as protecting from WannaCry, I guess I'm not understanding.
Yes, yeah, exactly.
I mean, it's all going to boil down to anything that comes out that's new. If traditional AV isn't able to catch it, you're in trouble. And an EDR system, while an EDR system is going to help you clean up the mess after the fact, it's a lot better. An ounce of prevention is a lot better than a pound of cure. And that's a good example here. If you were just able to prevent that from ever running on your network, it's a lot nicer than having to go out, clean up the mess, figure out what it did, what data was exfiltrated, and ultimately re-image the machines. That's part of our philosophy here, of course. Any machine that ever is owned, we believe, should be should be wiped and reloaded, including having the master boot record wiped. The whole idea of remediating a machine that's been owned is just a bad idea. And the idea here is prevent it from ever running on the machine, and then you don't have a problem.
Right.
Hey,
and prevention. So, sorry, go ahead, Walt.
Hey, Kim, just wanted to add something to that. You know, this piece of malware has affected ATMs worldwide. It's affected hospitals, obviously, in Europe. They're canceling outpatient support. A lot of countries were hammered at this. Very interesting kind of warfare. You know, it could be, who knows who it is. Could be a warfare thing, could be anything. My point being is we're going to see this continuing on and on and on and on. In terms of patching operating systems, I'm going to quote the great Ron White, the comedian, where he says, sometimes you can't fix stupid. You know, the reality is not everybody's going to have patches up to date. Not everybody's going to have the most recent code. And you're going to have users out there that are on the edge, and they're going to be going to sites they shouldn't go to. They're going to be downloading, they're going to be opening emails that they shouldn't be opening. And it's going to happen. The point is, when it does happen, what are you going to be able to do about it? And for me, and I'm going to plug Cylance here, it is one of the most effective means at preventing malware from the endpoint perspective. There are other means of helping from other avenues, which we put into our core strategy that Greg has baked for us. But at the end of the day, Cylance and the technology of machine learning and the mathematical models is very, very powerful. So folks,